Now that we know how to solve with graphing, we want to look at solving with another technique called substitution. The problem with graphing is that if our point of intersection isn't on a nice whole number, it's hard to estimate where we're intersecting with accuracy on a graph. For example, if our points intersected at 4 over 5 and 8 over 5, so x equals 4 over 5 and y equals 8 over 5, it's extremely hard to be able to look at a graph and be able to determine that kind of accuracy. So for that reason, we're going to have two other methods, substitution and elimination. So when we use substitution, our goal is going to, or I shouldn't say our goal is still going to be the same, to solve for the point of intersection. But we're going to know to choose substitution over elimination if either x or y, so one of the variables, is by itself already, or it's easy to get one of the variables by itself. Usually it's easy if we have a variable without a coefficient, so without a number out front. These are our steps we're going to follow. So we'll get one of them alone. Sometimes they'll already be alone, so we can skip step 1. We'll substitute what either x or y is into the other equation, use our techniques for solving to solve for the remaining variable, and then plug our solution to step 3 back into the original equation to find the other variable. So let's go ahead and dig in on example 1. There are 3 examples if you want to watch the first 2 and follow along with me. Example 3 is an excellent one for you to try on your own after pausing the video. So let's see, on example 1, according to step 1, I have to get either x or y alone. Well, I notice that in my second equation, y is already alone. So I like to number my equations. So here's equation 1, here's equation 2, which just tends to keep me more organized. And in equation 2, y is already by itself, so I'm going to jump to step 2, and I'm going to read my equal sign as is, and y is 12 minus x. So according to step 2, I'm going to sub that into the other equation. So I'm going to sub that into equation 1. Okay, and when I sub it into number 1, everything remains the same, except for instead of writing a y, I'm going to write 12 minus x in parentheses. And now step 3 tells me to solve. Okay, well, I'll first distribute. I'll combine like terms. I'll get rid of anything not attached to the variable. And then I'll divide to get rid of multiply, giving me x equals 42 over 5. I check to see if I can reduce 42 and 5. There's nothing they can both be divided by. So I'm going to go ahead and say I'm done with step 3. I solved for the variable that was left. I solved for the x that was present in equation 1. And now I'm going to take that solution and I'm going to plug it back into either equation 1 or 2 to solve for y. Because if I'm solving for my point of intersection, a point is always an x comma y value. So I'm going to go ahead and I'm going to use equation 2. And I'm going to put this into it. And I'm going to have y equals 12 minus 42 fifths. Well, I know 12 is the same thing as 12 over 1, and that in order to combine those, I'm going to need a common denominator, so I'm going to multiply top and bottom here by 5, giving me y equals 60 over 5 minus 42 over 5. So 60 minus 42 gives me 18 fifths. Well, now that I know both x and y, I can go ahead and say that the solution to this system is the point 42 fifths, comma 18 fifths. And so if I were to graph these equations out, that is the point where they would intersect. Looking at example 2, I'm going to lose my steps, but you should have them written down or have the notes template printed out so you can still see them. And so on example 2, the first step is to get one of the variables by itself. It does not matter which. I'm going to go ahead and see that I could get this x by itself fairly easily. All I would have to do is add 3. So again, to be organized, I like to label my equations 1 and 2. So I'm going to take equation 1, and I'm going to go ahead and add 3 to both sides to get x by itself. And I get x equals 2y plus 3. And this was equation 1, so I'm going to sub this into equation 2. And when I do, everything about number 2 stays the same, except instead of an x, I'm going to put this in its place with parentheses. So equation number 2 is now going to become 4 times 2y plus 3 plus y equals 8. And now step 3 tells me to go ahead and solve this, so I'll start by distributing. I'll combine my like terms. I'll subtract. And I'll divide by 9. And I get y equals negative 4 over 9. Once I know what y is, I'm not done because I know I intersect at a point, x comma y, so I have to find what x is. I can find what x is, according to step 4, by plugging this y equals negative 4/3 into either of my original equations. So last time I used equation 2, I'm going to go ahead and use equation 3 this time, or excuse me, equation 1. So I'm going to go back to equation 1 again, and I'm going to have x minus 3 equals 2 times negative 4/9. So then simplifying the right side is negative 8/9. I know with multiply, I multiply straight across. I'm going to go ahead and add 3. Well, I know adding 3 is the same thing as adding 3 over 1. And that in order to add these two fractions, I need a common denominator. So I'm going to multiply 3 over 1, top and bottom by 9 to get a least common denominator of 9. Combining like terms, negative 8 plus 27 gives me 19 over 9. So writing my answer as a point, x comma y, I get 19 over 9, comma negative 4 over 9. So again, if I were to look at the graphs of these two equations, they would intersect at this point. Also, if I were to plug this point in to both equations, I would notice that it gives me a true statement for both. Finally, moving on to example 3. Again, this would be an excellent one for you to go ahead and pause the video, try it on your own, then unpause the video to go ahead and see how you did. All right, now that you had a chance to try it on your own, let's look through it together. So looking at this, the first thing I want to do is try to get one of the variables alone. Well, it looks like everything has a coefficient, but x only has a coefficient of negative 1, so I'm going to go ahead and get that x by itself because it would be fairly easy to divide everything by negative 1. So I'm going to go ahead and take equation 1, and I'm going to go ahead and add 7y to both sides to start. And you did not have to get this x by itself. It's just probably the easiest, so I'm always going to use the easiest method possible. Then to get the negative gone, I'll divide by negative 1. Those will cancel, leaving me with just x. Dividing both terms by negative 1, I get negative 14 minus 7y. And now that was equation 1, so I'm ready to sub this into number 2. So I'm going to go ahead and take equation 2, and number 2 is negative 4x. So in place of x, I'm going to put this expression in parentheses. And now I'm going to start my solving process. So negative 4 times negative 14 I found to be 56. Negative 4 times negative 7, positive 28y. After distributing, I'll combine like terms. I'll subtract the 56 from both sides. And 28 minus 56 is going to go ahead and give me a negative 28. I'll divide by 14. And I get y equals negative 2. Again, I'm not done. I now need to go ahead and plug that back into one of my equations. I'm going to go ahead and choose equation 1 to plug it back into. And I'm going to say I have negative x minus 7 times negative 2 equals 14. So negative x plus 14 equals 14. I'll subtract 14. Oftentimes when we get an answer of 0, we don't put anything there, but if I don't have anything, I have to have a placeholder. So if it's 0 occurs on a side where other things are going on, I don't have to write it, but if it's the only thing there, I do have to write it. I'll divide by -1. Remember, it's okay to have 0 on top, so 0 divided by -1 is just 0, and my solution point is 0, -2. So hopefully you did well on that after you tried it. If you have any questions, please bring them with you to class. Make sure you bring these notes with you so you can use them as a tool, especially the steps up above, but also the examples, so you can use those as a reference point to see how to work these problems.